Okay. From this evening, we will learn a new subject, namely laboratory diagnostics. My name is Zhao Weidong. I come from the Department of the Laboratory uh, Diagnosis of the affiliated hospital of the Dai University. This evening, we will learn something about the laboratory diagnostics. What's the laboratory diagnostics? Okay. Tonight, we will discuss some topics. First one is about the concept of the laboratory diagnostics, and that means what is the laboratory diagnostics. The second part is about the contents of the laboratory diagnostics. Third part is about the laboratory diagnostics standardization. And the first part is about the specimen collection, transport, and storage. And the fifth is about fifth part is about the we will learn some of the factors affecting the result of the testing. Last part is about the standardization of the methods. Okay, next we will learn one by one. First one, next is about the learning objective. After this course, you will be able to describe the concept of the laboratory diagnostics and summarize the content of the laboratory diagnostics, and to describe the procedure of the laboratory diagnostics standardization, and to recognize the specimen collection, transport, and storage, and to explain some factors affecting the results of the testing. Okay, next we will learn the topic one. It's about the concept of the laboratory diagnostic. Concept of what is this? First is overview. Is overview about the laboratory diagnostics. Besides the physical diagnosis and imaging diagnosis, laboratory diagnostics makes an important contribution to the diagnosis of disease. With the rapid development of laboratory diagnostics, it plays more and more important role in clinical diagnosis, serving as an important bridge between basic medicine and clinical medicine. Laboratory diagnostics refers to using a specimen which collected from the human's body, including blood, body fluid, secretion, and excrement. And we will select suitable reagent and some instrument analysis, quality control, and system management, and then get the accurate results. Their results are provided to doctors and other healthcare professionals with information as follows. First one, laboratory diagnosis. The results of the laboratory diagnosis is for the disease diagnosis. For example, we can test the blood sugar for the diagnosis of diabetes, diabetes mellitus. And second, we can differential. It can help for the differential diagnosis. And third, can guide for the treatment and monitor efficiency of the therapy. And the first is for the prognosis assessment. And the fifth is for prevention of disease and conduct scientific research. We can collect some data of the same type of the disease and to write some scientific paper. Seventh is health status evaluation and early warning of the high risk condition each year. So we recommend each year or every 2 years to have the healthy checking. Therefore, laboratory diagnosis is an compulsory and key course for clinical medicine students, and includes basic knowledge and skills for clinician. Through systematic learning, medical students should master the diagnostic methods, make full use of the information, and improve the diagnostic ability. Okay, sorry, this is the course schedule. This is the third semester. Okay. Theory class, we have the 28 period. From we will have this course for 7 weeks. Topic 2. Next topic is the contents of the laboratory. The modern clinical laboratory offers a large repertoire of the tests on blood, urine, stool, and body fluids. A full-service laboratory provides chemistry, immunology, hematology, microbiology, molecular diagnostics, and immunohematology testing tests. So, in the department of the laboratory diagnostics, there are including many laboratories, many sub-laboratories, such as the clinical hematology and the body fluid examination. In Chinese means 临床血液学排泄物、分泌物及体液检验。And the second one is the clinical biochemical examination, means 临床生物化学检验. It's for some the blood sugar and blood fat and other biochemical items. Third is for the clinical immunology examination. Chinese means 临床免疫学检验. We can use the immunology assay to determine some infection disease and some autoimmune disease. First is clinical microbiology examination. Means 临床微生物学检查. We can test the bacteria, fungus, and other pathogens. Fifth is molecular biology examination. In Chinese means 分子生物学检查. You know PCR. We can test the DNA or RNA of some pathogens. For example, the HBV DNA and HCV RNA, and also we can test the COVID-19 virus RNA. Six is about the genetic examination. It's from Chinese means 遗传学检查. 遗传学检查. So next is about the benefits of the laboratory diagnosis. When used appropriately, diagnostic through early treatment. Laboratory tests can also help us to evaluate the severity of disease and estimate prognosis of disease, and also for monitoring the cause of disease and finding disease recurrence, and finally select some appropriate drugs, and also to adjust the therapy approach. Costs. Laboratory diagnosis maybe total costs may be high. Laboratory tests as a whole count for about 15 to 20% of the healthcare expenditures in China. But as we know, a sword have two sides. There we have learned the benefits of the laboratory diagnosis. Next is for the risks of the laboratory diagnosis. A false positive test may lead to an incorrect diagnosis or further unnecessary testing, or sometimes can lead to some medical disputes. Next is about the characteristic of laboratory diagnostics. First one, laboratory examinations have undergone revolutionary changes over the past decades. More than 80% of clinical inspection system with the characteristics of the high accuracy and precision and multi parameter and advanced intelligence and high throughput and speed. Laboratory tests can be valuable aids in making a diagnosis, but as a screening tool for detecting hiding disease in symptomatic individuals, their usefulness is limited. The value of the test as a diagnostic it depends on its sensitivity and specificity. So sensitivity is the measure of the percentage of individuals with disease who have a positive test results. For example, people with the disease who are correctly identified by the procedure, and specificity is the measure of the percentage of people without or free of disease who have a negative test results. For example, healthy individuals correctly identified as free of the disease. So if a test is 1% sensitivity and the test result is negative, it can be said with certainty that the person does not have the disease, because there will be no false there will be no false negative results. If the test is not specific enough, however, it will yield a large number of the false positive results. Positive test result for those who do not have the disease. The ideal test would be 100% sensitivity and 100% specificity. An example would be an early pregnancy test that was so accurate that it was positive in every woman. In every woman who was pregnant and was never positive in a woman who was not pregnant. Unfortunately, no such test exists. The normal value for test is based on 95% of the population tested being afraid of the disease. Meaning that 1 out of every 20 tests results in healthy individuals will be outside the normal range and therefore positive for the disease. With the advent of the automatic analyzer, an increasing number of the number and variety of the tests were made available at great reduced costs. A panel, the chemical test for blood and urine, have become routine components of the basic medical workup. Blood analysis and urine analysis are used to detect and measure a variety of the substances. For example, count of the different types of blood cells and information about the presence of the infection agents can be obtained by blood. 在外面呢。好了，等一下。Levels and metabolic products and other chemical substances are often easily detected by urinalysis. 很好，接你妈的电话。There also exists a variety of the specific types of the analyses, including immunologic blood tests, glucose tolerant tests, genetic tests, and toxicology tests, all of which can provide valuable diagnostic information. In the case of the certain blood and urine tests, the normal laboratory value is one that falls within a range that represents most of healthy individuals. However, it is clear that some healthy persons will have values outside that range, and some individuals with disease who have values or have the results within the normal range. Therefore, no sharp lines divide the normal and abnormal values. Tables of the normal reference values must be updated regularly to react to change in laboratory technique. Many normal values vary dramatically with age and gender. Worldwide, the standard for reporting laboratory measurements is the International System of Units. The United States is the only major industrialized country that has not adopted the international system and continues to use customary units of the measurement. Most tables provide both units to facilitate communications and understanding. For maybe for 3 decades, when we tested blood samples, we are basically tested the different samples, blood samples, urine samples by manual. We need to use the microscope to observe the different types of the WBC and to count the numbers of the different substances. With the development of the automatic analyzers, maybe 2 decades, we use some semi-automatic analyzers. For example, some the hematology analyzer and urine analyzers. So we can see this hematology analyzer, these two machines, these two analyzers is just semi-automatic analyzers. Semi-automatic analyzers the items tested in this analyzers is limited. For example, we can just to determine 18 items about the blood in this semi-automatic analyzers. And use these urine analyzers, we just can test 8 items. So and recently, the fully automatic analyzers is applied in most of the laboratory of the hospital. We can find here are two machines. The left one is for the fully automatic analyzers, is for the biochemistry, and the right one is hematology analyzers. Is for the blood, the whole blood test. We can test more than 25 items of the blood samples with this hematology analyzer. In some biggest laboratories of the hospital, we combined the different fully automatic analyzers together and to form the assemble lines. So one blood samples can be tested by the different machines in the assemble lines. So next, according to the different testing projects, clinical laboratories can choose the reagents produced by different manufacturers, and I do test method require international standardization. And it is important that the sensitivity and accuracy of the testing must be the best level. Usually, clinical laboratory technicians use scientific methods and management measures, such as international quality controls and external quality assessment, to evaluate the experimental tests, including sensitivity, specificity, positive predictive value, negative predictive value, etc. These methods ensure the very accurate and reliability of the experimental results effective. Next topic is about the laboratory is about the standardization of the laboratory diagnostics. So laboratory diagnosis provides the objective results for the clinical decision. With the development of the biochemistry, molecular biology, immunology, and hematology, the diagnostic techniques and methods are constantly under standardization, which directly regulated the subject much more objective and scientific than ever. In order to standardize the clinical experiment, many factors should be considered. So the factors include specimen collection, specimen transport, and specimen storage, and the physical factors, and some reagents and instruments, etc. Next topic is about the specimen collection, transport, and storage. Examination results. The results are affected by manufacturers. First one is the specimen collection, and the specimen transport and storage, and detection methods, and instruments, reagents, and personnel quality. The physical state of the patient also affects the test results. So next slide is for the specimen collection. First type of the specimen is the blood. So blood is a very important types of the specimen from the clinical department. The specimen types, the blood specimen types include the whole blood. It is used for clinical hematology examination, complete blood count. For example, the total number of the RBC, the total number of the WBC, and the total number of the platelets, and the percentage of the different types of the leukocytes, and the volume of the RBC, the volume of the platelet, the cytological classification and morphology determination. And second type of the blood is the serum. It is what's the serum? It is light yellow transparent liquid after natural coagulation of the blood in vitro. the fiber has been removed, and it is mainly used for clinical, chemical, and immunological analysis. Plasma. After mixed with the anticoagulant and the centrifuge precipitation, the upper layer yellow liquid was isolated, which contains a fibrinogen and blood coagulation factor, can be used for the uh, chemical uh, hematostasis and thrombosis analysis. And different purpose should so according the introduction about these three types of the blood, so different purpose should select different blood samples. Uh, Next slide is about the blood collection. Blood collection classification of the blood samples. First one is the capillary blood. Capillary blood is suitable for the infants, outpatient, and the burn patients. Mainly used for the point of care test. Is short of aberration, POCT, or emergency test. And venous blood is the most commonly used. Usually select elbow vein, wrist vein, hand vein, and even external jugular vein for infants. Arterial blood is used for the blood gas analysis. Usually select the femoral artery um, and the brachial artery. Next is about the sampling time. Sampling time. First one is about the fasting blood time. Fasting blood samples. Usually in the morning before breakfast, patients should keep at least an hour fasting to collection blood. This type of blood commonly used in the chemical tests. The advantage is that it can avoid the interference of diet and physiological activities. A special time of the blood sample. Some blood components change along with the physiological cycle, such as hormone and glucose etc. Next is about is for the random blood sample, usually used for the for some emergency patients. Okay, next slide is about some of the anticoagulants. Okay, what about have a rest? Have a 10 minutes break. Okay. Uh, this slide is for the anticoagulants. So next, I will demonstrate some anticoagulants for you. First one uh, is the EDTA. Is the abbreviation for the ethylene diamine acetic acid. The EDTA, the anticoagulant mechanism of the EDTA is uh, to chelate with the calcium ion, mainly used for the hematology cell count, cell morphology examination, ABO type, and RH type detection, antibody screening, etc. Second is the heparin. It can strengthen the anticoagulant effect of the antithrombin. Heparized plasma is used for the osmotic fragility test of the RBC, blood gas analysis, clinical chemical examination, etc. Third one is citrate sodium. Citrate sodium. The mixture consists 1 part of the sodium citrate and 9 parts of whole blood, mainly used for the hemostasis and thrombosis examination. For the erythrocytes sedimentation reaction, 1 part sodium citrate and 4 parts of whole blood are collected in this test tube. First anticoagulant is fluoride. Fluoride. This active results in the inhibition of the both coagulation and glucolysis, and it is used for the blood glucose determination. Next is about the another type of the samples, for example, marrow, urine, and other body fluid collection. We will learn in the following sections, in the following chapters. Now, okay, next slide is for the specimen transport and preparation. The samples must be transported in a correct manner after collection. The separation of the serum or plasma from the whole blood should be completed within 2 hours since collection. Serum and plasma must be tested and reported whether there are hemolysis, lipemia, and bilirubin, which can interfere with the test results. Next slide is for the some lipemia samples. These 3 small tube. This small tube the blood sample in this small tube is normal. Left two samples is the lipemia. We can see there exists so many fats in the serum. The medium picture for the is a sample of the hemolysis, and right pictures is the bilirubin. We can see this small tube is normal. The serum of this small tube is heavy blue, not heavy yellow, heavy yellow. Okay, next slide is for the specimen storage. Serum and heparin-based plasma for the determination of the enzyme and substrates can maintain stable for 1 week at 4 degrees to 8 degrees centigrade. Plated poor saturated plasma for hemostatic and thrombosis examination can maintain stable less than 18 hours at room temperature. EDTA blood for the determination of complete blood count without a differentiation count but include a platelet count can maintain stable for 24 hours at room temperature. Isolated serum for detection of serum proteins, including immunoglobulins and specific antibodies, tumor markers can store for up to 1 week at 4 to 8 degrees centigrade. A long-term storage temperature lower than minus 20 degrees centigrade is required. Sharp freezing is important for maintaining the structure of the proteins. The process of the thawing must occur very slowly, either overnight at 4 to 8 degrees centigrade or in water baths under constant agitation. The sample must be well mixed before analysis. So, in the laboratory of the hospital, we can different type of the refrigerator for different samples. We there have the minus this refrigerator. The temperature of this refrigerator is minus 70 degrees centigrade. This refrigerator is from the 2 to 8 degrees centigrade. Okay, next topic is for some factors which will affecting the results. First factors is the physiological factors. In preparation a patient for drawn blood, we should take care of them and minimize factors which can related to activities that might influence laboratory results. So the factors include diurnal variation, exercises, fasting, diet, drink, tobacco smoking, and medicine intake and posture. So first one is the diurnal variation. It may be encountered when testing for hormones, iron, acid phosphatase, and the urinary excretion of the most electrolytes such as the sodium, potassium, and phosphorus. Exercises will influence the will affect the calcium, phosphorus, potassium, sodium transformase, urine, uric acid, bilirubin will be doubled after exercises. Therefore, before blood is collected, the patient should have a rest and avoid strenuous exercises. Third factors is gender. Quite a lot of laboratory tests, such as the hemoglobin, gamma GGT, and PG, uric acid, creatinine, and ammonia, CK, AST, ALP, iron, urine, cholesterol, etc. can change widely according to the different gender. For example, the reference value for the adult male of the RBC is the 4 to 5.5 multiplied into the 12th power per liter. The reference value of the hemoglobin is 120 to 160 gram per liter. And for the adult female, RBC reference value is 3.5 to 5.0 multiplied into the 12th power per liter. And hemoglobin is 110 and to 150 gram per liter. For new baby, the RBC is 60.27 multiplied into the 12th power per liter, and hemoglobin is 170 to 200 gram per liter. So maybe different tests in the different gender, the results are different. Next factors is race. Racial differences are important in the frequency distribution of the blood group determinants. Next factor is age. Older people increase blood glucose, urine, cholesterol, LDH activity, etc. will increase in the older people. The calcium phosphatase, total protein, albumin will decrease in older people. Childhood, in comparison to adults, higher enzyme activities are found, whereas iron, copper, and immunoglobulins have a lower concentration. Next one is the alcohol intake. A few minutes after the intake of the alcohol, AST rises slowly, and 3 hours later can reach the maximum, which usually falls within the reference intervals of the non-drinkers. After time and delay, there is a slight rise in GGT. The effect on other enzyme activities is hardly measurable. Next factor is the tobacco. Long-term smoking can increase the hemoglobin, red blood cell, leukocyte counts, and insulin, and epinephrine, and growth hormone. Smoking also affects the body's immune response. For example, the hemoglobin A, IgG, and IgM are lower in smokers, while IgE levels are higher. Comparing with the non-smokers, research has shown that sperm counts and activities decrease while the ratio of the abnormal morphology sperms increase. Next one is the posture. So an upright position increases the hydrostatic pressure, causes a reduction of the plasma volume, and increases the concentration of the indices such as the ALP, cholesterol, TG, copper, and the cellular-plasmin, transferrin, and leukocyte count, progesterone, and estradiol, and estriol, prolactin, whereas HCG and alpha fetoprotein can be found under the pregnancy. On the contrary, iron and Mg, calcium, total protein, albumin, and cholinesterase, hemoglobin, and HCT and RBC count will decrease. So above is about some factors will affect the testing results. Next topic is about the standardization of the methods. Laboratories must assess the reliability of the experiments methods, understand the methodology, performance of the testing. So here are some concepts about the standardization of the methods. First one is precision. It is the reproducibility of the measurement and the prerequisite for accurate. But high precision is not necessarily guarantee high accuracy. It contains with batch precision and inter-batch precision. Second is false accuracy. It is the close degree between observation value and true value, made affected by systematic errors. Okay, please wait. Okay. Okay, next concept is the sensitivity. In Chinese means 敏感性. It describes the ability of the method to differentiate between values adjacent to each other. It indicates to what extent a value changes depend on the signal of the system to be measured. The sensitivity can be quantified by slope of the calibration lines. Next one is the specificity. In Chinese means 特异性. It is the ability of the method to find only the analyte under consideration. Other components of the samples should not affect the analytical result. Next is about the reagent and the instrument. The technicians are responsible for the management of the instrument, should establish instrument archives, standard operation procedures, using requires regular maintenance, instrument calibration and verification procedures requires, and makes the instrument to meet the requirements of the standards. Experimental reagents should be managed by special technicians. All reagents should be used within the period of the validity. If batch number is changed, technicians need to be carried on the comparison experiment. Personnel quality. It is important for an operator or for a technician to have enough base theoretical knowledge, skilled technique, development seeking, rigorous spirit, noble medical ethics for providing credible results to clinical departments and research. Next one is for the quality management system. Laboratory error is defined as any defect from the order, task to reporting and interpretation of the results. Laboratory errors have a reported frequency of the percentage of the 0.012 to 0.6 of all test results, which in turn has huge impact on diagnosis and patient management, as 60 to 70% of the all diagnoses are made on the basis of laboratory tests. Laboratory quality can be defined as accuracy, reliability, and timeliness of the reported test results. To be useful, laboratory results must be as accurate as possible. All aspects of the laboratory operations must be reliable, and the reporting must be timely. Some significant consequences of the poor quality in the laboratory can include unnecessary treatment or treatment complications, failure to provide correct treatment, delayed diagnosis, and unnecessary follow-up diagnostic testing. These consequences result in increased cost in line and work, as well as poor patient outcomes. Total testing process in the laboratory is a cyclical process divided into three phases: pre-analytical and post-analytical phases. To ensure the quality of the laboratory work, technicians must do the total quality management. The goal is to manage the experiment process and service in a continuous and comprehensive way, monitor each testing needs, and meet the clinical request. The pre-analysis of quality control. Appropriate test ordering by physicians. The most important pre-analytic procedure performed outside the laboratory, also called the pre-analytic phase, is formulating a clinical question and selecting appropriate examination techniques. Although the inappropriate test ordering does not directly affect the patient's care, it results in patient inconvenience and an unjustifiable increase in cost. Um, and next is about the patient specimen identification. The most fatal types of the pre-analytical error, which occurs rela relatively common is improper patient identification or mislabel of the test tubes. Misidentification of the patient can lead to their being diagnosed and treated, and their conditions managed based on the laboratory results from other patients. For this reason, patient identification and correct labeling are the most important tasks, not only in the testing process, but in all areas of the healthcare. Specimen next is after um, the the right order given the physicians. Next step is the specimen collection. So the second most essential requirement to reduce laboratory error during the pre-analytical phase is specimen integrity. Specimen integrity depends on the number of the process performed, such as the specimen collection, maintenance of the specimen physiology, transportation, and procession. Next, about the analytical process quality. During the past few decades, the number of the laboratory errors in the analytical phase have increased dramatically. Such a drop is not only due to the increased automation of laboratory processes, but also has resulted from the introduction of the external quality assurance program to assess the quality of the testing results. Still, analytical quality is a major issue. A number of the issues must be tackled by laboratory directors to ensure the low error rates that are possible in this phase. Some of these issues are as follows. The participation of the laboratory in an external QC program and in external quality assessment procedures does not directly ensure that the results reported by the laboratory are accurate and precise. Available data does not demonstrate that clinical laboratory compile consistent with evidence-based quality specifications. Laboratories usually does not calculate the allowable total errors for all tests performed on all analysis. Although this would improve the diagnostic process. So different laboratory report reference values are non-specific for age, sex, age, gender, and physiological conditions such as pregnancy. Next is for the internal quality controls. The QC program that is inactive by the laboratory at its own level to assess its daily performance is called the internal QC program. This program uses continuous checks to ensure that the established reliability of the work of the laboratory does not fluctuate and that reports have been validated before they are released. It demonstrates not only the precision of the results, but it's also a checkpoint which reagents, instruments, and the proficiency of the laboratory personnel are assessed. First is about the external quality assessment. All the errors arising in the laboratory related to the accuracy and precision of the process of the analysis cannot be detected merely by use of the internal quality control program. Depends on only intra-laboratory statistic as in IQC can lead to lack of the awareness of the gradual or sudden changes in the test system, changes that are not under the control of the laboratory. So IQ, LQC is defined by the World Health Organization as objective evaluation. EQE is that the same materials is sent from a national or regional center to a large number of the laboratories. It is important that EQE be performed at regular intervals. So it is important that EQs can be in this retrospective analysis, the performance of individual laboratories is compared with that of other laboratories and within its own previous performance by calculating the standard uh, deviation index and accurate score. So next is about the post-analytical quality control. First one is peer review. Peer review is the most widely used method to determine diagnostic accuracy and to prevent diagnostic errors in testing involving uh, microbiology and pathology specimens. To, to, to our knowledge, to the best of our knowledge, no single method has been proven superior to and more acceptable than peer review in detecting errors. Most laboratories use multiple strategies to detect errors, such as the review of the cases for conferences, review of the cases by peer group before sending out results, and a review of the selected percentage of the causes of the specific types of cases. The most common types of the peer review method is second review by another pathologist before the first laboratory personnel signs off on cases. Um, Next, about the quality management system, QC requirements are um, mandated by regulatory agencies and must be followed by the laboratory to fulfill uh, accurate, accurate accreditation requirements set forth by those regulatory agencies. ISO International Standardization Organizations standard medical laboratories requirements for quality and competence. Design, design defines a set of the requirements that laboratory must fulfill to pass the accreditation requirements set forth by accreditation agencies. Some accrediting organizations use the information in ISO 15189 to guide the inspection or testing and accreditation process. Okay, while the International Standardization Organization standard provides broad-based guidance on implementation of the regulatory requirements, other standards are available for the laboratory that gives step-by-step detailed guidance on how to fulfill these requirements. Implementing a QMS in the laboratory is essential to providing quality test results and patient's care, and is a requirement for passing and maintaining laboratory accreditation. Okay, about the content of this tonight. So during this class, we have described the concept of laboratory diagnosis and the content of the laboratory diagnosis and the procedure of the laboratory diagnosis standardization and recognize the specimen collection, transport, and storage, and some factors affecting the results of the test. Okay, okay, thanks for your attention.